For this lesson, we're going to look at how we can construct equations and also how to balance them. Okay, so if you look at this worksheet, okay, writing chemical equations, I want you to skip all the way to this part of the notes. Right, so in all chemical equation, you need to know what are the structure in a chemical equation. A product. A chemical equation is made out of reactant and a product. Okay, the reactant is always on the left hand side and the product is always on the right hand side. So left hand side and this is right hand side. It's always this case, and they are separated by an arrow. You cannot replace this arrow with anything else. Okay, there are different types of arrows in chemistry, but you cannot replace it with like equal sign or whatnot. Okay, as chemical substances are known as reactants. Things that react together are basically reactants. There is another name for reactants. They can also be called reagents. React, we will form products. So we can represent the reaction in two ways. There's two types of equations. There's word equations and there's chemical equations. Word equation is rarely used. It's only like a beginner level. Okay, and then whereas you're expected to write chemical equations all the time. So when they ask you to write an equation, you must write a chemical equation, not a word equation. Oxygen react. We'll start with writing the word equation, and then from there we can go on to the chemical equation. So what does a word equation entails? It's just writing out the name of the chemical substances. So for example, hydrogen and oxygen react to form water. So it's just hydrogen plus oxygen give me water. That's it. So this is a word equation. Okay, so let's try other word equation A, B, C. Okay, so we'll do this together. So sodium react with sulfur. So you need to identify what are the reactants. So this is a reactant and this is a reactant because they react with each other. And what's the product? It's sodium sulfide because it produces sodium sulfide. Okay, for B, hydrogen gas is a reactant, fluorine gas is a reactant, hydrogen fluoride is a product. Okay, so what I want you to do now is, let's say you wish to try it yourself, you can pause or you can skip this portion of the video, or you can just pause and then check your answers later. Okay, plus sulfur, so word equation will give me sodium sulfide. And next one, hydrogen gas, fluorine gas, hydrogen fluoride. Fluoric acid reacts with sodium hydroxide, so form this is reactant, sodium hydroxide is a reactant, and then sodium chloride and water is formed. That means sodium chloride is a product, water is a product. So hydrochloric acids. So it's very important for you to really be able to identify what is a reactant and what is a product. It will make life so much easier for you. Okay, I have no space, so I'll write downstairs. But if you have space, please don't write it like this, because for equations it needs to be in a straight line actually. Is to change. So now our task is to change the word equation into a chemical equation. So a chemical equation means you will be writing the chemical formula of the reactant and the product. So for example, hydrogen is a diatomic. Chemical formula for hydrogen. Hydrogen is diatomic. Okay, so diatomic means it exists as twos instead of singles. So hydrogen, chemical symbol of hydrogen is H, and because it exists as two, there will be H2. Oxygen also, its symbol is O, because it exists as two, it will be O2. Then next, water is H2O. Okay, so then we will just substitute this into the word equation. So instead of hydrogen, you write H2. Okay, instead of oxygen, you write O2. Instead of water, you write H2O. Okay, so now what I want you to do is, we're going to skip this first, the balancing. I want you to write down, okay, go to this page, page 5, and I want you to just write down the chemical equation, the chemical A, B, and D, because that's what we did just now. Okay, so you can pause the video right now, okay, and then you can check the answers. So sodium is a metal, so metal is written as single. React with sulfur is also written as single, okay, and then you get sodium sulfide. So sodium sulfide, let's identify first whether it's ionic or covalent. So this is an ionic compound because it's a metal and non-metal. So then if it's an ionic compound, then you need to write down the ion. So sodium ion is Na+. And then sulfide, because it's in group 6. So remember I said group 6 minus 8 is equal to minus 2. So sulfide is S2 minus. Okay, remember this is sulfide, not sulfate. So this will be Na. I need 2 sodium, 2 S. Okay, so then let's go on to B. Hydrogen gas is also diatomic. Nitrogen, fluorine gas is also diatomic. Because remember, hydrogen, oxygen, nitrogen, and group 7. These are all diatomic. So it's H2 plus F2 will give me hydrogen fluoride is covalent. So covalent, you just refer to the name. So since they never said there's any numbers here, there's no mono, di, or tri, you assume there is only one. The same goes for fluoride, there's only one because there's no prefix, there's no indication in front of the element. Okay, next, hydrochloric acid, so then HCl plus sodium hydroxide. So again, this is an ionic compound, so this is Na+, and then hydroxide is OH minus. So this is overall 0, so it just remains as such. Okay, then this is also ionic compound. It's a product, right? It goes to the product, so then after that, this is an ionic compound. So this is Na+, this is Cl minus, is group 7. So it becomes NaCl. Plus water, you know, is H2O. So that's it. You have what we call an unbalanced chemical equation. Okay, so now let's move on to balancing. Okay, now why do we need to balance? We need to balance because you need to show exactly the recipe. So how many tablespoons of or how many bags of hydrogen do I need to react with oxygen to give me how much water? So the chemical equation is essentially a recipe for chemist. Okay, so let's chemist. Okay, so let's do the counting. So the whole idea behind balancing is actually to make sure the left hand side number of atoms is the same as the right hand side number of atoms. So if we check here the unbalanced equation, I have 2 hydrogen atoms, 2 oxygen atoms. For on the right hand side or the products, I have 2 hydrogen atoms, so this one no problem, but I only have 1 oxygen atom. So this is my problem area. So how do I make this the same? Okay, so in order to make the same, I will write numbers called coefficients, okay, in front of the chemical formula to balance it out. So what are coefficients? Let's move on to page 1 first. A coefficient is what you put, a number you put to multiply in front of the chemical formula. So for example, if I put the coefficient 2, the number 2 in front of Al2O3, then the whole thing is multiplied by 2. And this only applies in chemical equation. It doesn't apply for MR and AR. you'll balance it out. So how can I balance this out for hydrogen and oxygen? By multiplying maybe the water with 2. Okay, because I want to make the oxygen 2. Can you see original oxygen is 1. So how do I make the how do I make the oxygen 2? Okay, by multiplying this by 2. But the problem with multiplying it by 2, now my hydrogen becomes 4. Okay, because 2 times 2 of hydrogen is 4. 2 times 1 of oxygen is 1. So in this case then, what do I need to do? I need to go back to the left hand side. Then I need to multiply this by 2. Can you see here? 2. Then my hydrogen becomes 4. Then now it's balanced. Can you see? 4 hydrogen, 2 oxygen. So this takes a lot of practice. Okay, so you need the practice. For this, you really need to practice also. Okay, so now we call the chemical equation balanced. Try this activity first. Okay, then on Wednesday, which is tomorrow, during the live lesson, we'll do the group activity. It's already inside your notes. Okay, so now next, let's look at this. Let's balance it. Okay, so if I look at here, sodium, sulfur, sodium sulfide. So I have 1 sodium, 1 sulfur, then on the right hand side 2 sodium and 1 sulfur. So the problem is with my sodium. So what can I do? I can multiply my sodium by 2, because this is 2 and this is 1. So I'll put 2 in my hand. So when this happens, now I have 2 sodium on each side and have 1 sulfur on each side. So I'm balanced. Okay, now let's try the hydrogen gas. So at this juncture, you can pause the video, try it yourself, and then come back to the video to check your answer. 2 hydrogen. For hydrogen gas, I have 2 hydrogen, 2 fluorine, 1 hydrogen, 1 fluorine on the right hand side. So maybe I can just put the number 2. Now I have 2 hydrogen and 2 fluorine on the right hand side, 2 hydrogen and 2 fluorine on the left hand side. So this is balanced. Okay. Now let's look at D. Now D is a little bit more complicated because my hydrogen is split. Okay, but it's okay. You'll just count it together. So how many hydrogens do I have? I have 1, 2. So I write there 2 hydrogen, 1 oxygen, 1 chlorine, 1 sodium. The other side, 2 hydrogen, see, 1 oxygen, 1 sodium, and 1 chlorine. Okay, so everything's the same. So this is balanced. I don't need to put anything. Okay, now you can try part C yourself.